There are quite a few times where KiCad default footprints won't be sufficient for the project. In this case, we are either forced to create our own footprint or try to find a footprint online for the component that we are working with. In this video, we'll see both the methods where we initially create the footprint using the footprint editor, then add external footprint which we found online. In our PCB, there are quite a few things that needs to be optimized. Look at the cell holder, for example. The 3D model is way smaller than the actual footprint. That's because we used a different size cell holder as an alternative instead of using the actual footprint. Because KiCad cannot hold all the footprints that's available on the market. Now let's try to fix this by making our own custom footprint. We can't just dive into the footprint editor just like how we did with the symbol editor. To make a custom footprint, we need to have proper details about the components like the shape and its dimension, because the footprints will reflect the physical component. Luckily, I could find the datasheet for the cell holder I have, which has very precise measurements. With these values, we can jump into the footprint editor to create the footprint for the cell holder. Just like how we open the symbol editor, we can do the same for the footprint editor. You can either click on the footprint editor icon from the PCB editor, or you can directly access it from the KiCad's project window. This footprint editor has tools and navigations that are very similar to the KiCad PCB editor, except we have all the footprints that are available on KiCad arranged here alphabetically. To start, we'll create a new library just like how we did for the custom symbols, so this way we don't mess up the default ones. Go to File, click on New Library. And I want this footprint to be available only on this particular project. So I'll select the project option and then click on OK. Now while naming, I'll try to use KiCad's naming convention. So the name of the library will be something like cellholder_txt. This is not mandatory, but trust me, it will help a lot while managing a huge amount of custom libraries. For now, I'll just click on Save. And then we'll select the created library. And then click on Create New Library using this icon. And I'll name the footprint as cellholder CR2032. And make sure the footprint type is through hole. And then click on OK. With this, we have the library set up. Make sure you change the grid size to 10 mils to make the drawing more precise. Now with these settings, let's try to draw a shape of the PCB with proper dimension from the datasheet. Now I'll just move these values aside and make sure the front silk layer is selected and select the circle tool. And I'll draw the circle slightly larger than the diameter we need. So I'll make the radius slightly larger than that's required. This will make sure the silk layer is visible even after we solder the components. Once that's done, we'll go to the circle properties and change the thickness to 0.15, which is recommended by the KiCad's convention. Then click on OK. Next, let's add some paths so we can place the components on the footprint and solder them. For this, we can use the path tool. And then click on the places where we need the paths to appear. And always remember, the pad 1 should be on the left side of the footprint. KiCad uses the pin information to associate the schematic symbol with the footprint during footprint assignment. So make sure the pad numbers and the pin numbers match each other. For example, if the battery symbol have positive on the pin 1 and negative on the pin 2, the footprint should have positive on pad 1 and negative on pad 2. We need to be very careful at this stage so this doesn't mess up our entire circuit. Currently, I place the paths just eyeballing it. But we need to make sure it's very accurate. So I'll use the data sheet along with I'll use the measure tool and the dimension tool to make the placement of the paths very precise. Now with that done, I'll try to make the shape very similar to the component. So first let's add the excess part over here. We can easily do that by using the line tool. This circle can be a little annoying because we can't get rid of this excess part. And KiCad also does not provide a trim tool where we can just delete this particular section. Instead, we can use the arc tool to recreate this curve. So I'll use the arc tool. I'll select the origin. I'll select the starting point, then the ending point. Now we can delete the circle that's behind the arc. This footprint should be sufficient to be used on our PCB. But according to KiCad's convention, there are a few more steps that we need to follow. First, we need to make sure the shape of the pad 1 is rectangular. So click on the pad 1 and then go to properties by clicking the shortcut letter E. And here under pad shape, click on rectangular. While we are under the settings, you should also make sure under copper layers, all copper layers are selected and both front and back copper mask is selected. Then click on OK. These settings were not mandatory, but it will help us create a footprint with very minimal design error. Now there is only one last step remaining to complete the footprint. That is to add some courtyard to the footprint. We can do this by selecting the front courtyard and then using the arc tool again. We'll draw the curve with a clearance of 10 mils from the silk layer. Then I'll use line tool to finish the rest of the graphics. Now to verify that the footprint has been included into our PCB layout library, we can go to the PCB editor, click on Preference and then click on Manage Footprint Libraries. And under this, if you go under Project Specific Library, we can see the custom footprint that we created, that is cellholder_txt. Now let's see how this custom footprint will affect our PCB. I'll just click on OK. Let's select the cell holder footprint, then right click, then click on Change Footprint. And here make sure Change Selected Footprints is checked, and then under New Footprint Library ID, click on this icon and search for cellholder_txt. Then double click the cellholder CR2032. Finally, click on Change. You can see after few adjustments, we have successfully updated our custom footprint on the PCB. Alternatively, we can also search for components online and then replace the footprint. Especially if you're using sites like Mouser, you can easily find the footprints for the parts that you purchased. But if you shop somewhere else or buy it offline, you can always end up using third-party sites like SNAP EDA or OCTO. Since we have already downloaded the part from the SNAP EDA in the previous video, we'll just see how we can add that part here. I'll go to the Manage Footprint Libraries again, and under this, I'll click on this folder icon. And here I'll navigate to the folder and select the folder where we have the KiCad_mod file. In this example, I'm using 80tiny85 because that's what we downloaded in the previous video. Now let's try changing the 80tiny85 on our PCB with the ones that we downloaded from SNAP EDA and see how that affects our PCB. It's not that bad, but I preferred the previous footprint. So far, we figured out how to make custom symbols and custom footprints. In the next video, we'll see how we can put all the experience we gained throughout the series and optimize the PCB for production. Until then, if you have any questions or doubt, you can always reach out to us at PCB Cupid Q&A. If the video was helpful, like and subscribe to the channel and also share it with people who might love this kind of content. Until then, keep learning and keep creating.